Until now, we looked at the requirements, functional, logical, and software design of our little friend here. So let's dive into the final part of the robot's physical viewpoint, the hardware design. In the final part of this tutorial series, I will demonstrate how to model a system's hardware architecture as part of the physical viewpoint. Then I will show you how to link the hardware architecture to the hardware requirements, the logical architecture, and the software architecture. Let's begin. To model the hardware architecture of our robot vacuum cleaner system, we open the Hardware Architecture category of the Systems Engineering Explorer. Here, for example, let's open the package containing the components of the robot vacuum cleaner hardware architecture. To get an overview of the hardware architecture, let's open the Hardware Network Diagram, which is included in the package. The diagram shows the connections and locations of the hardware components. For example, the front of the device has 3 ultrasonic sensors. The top has a LiDAR and the bottom has a cliff sensor. These sensors are connected to an embedded control unit on which the central navigation and routing system is implemented. When we draw a new connection in the diagram, it is automatically routed. For example, let's connect the currently unconnected ultrasonic sensor on the right to the ECU. Based on the data it receives from the sensors, the central navigation and routing ECU controls the motors of the left and right wheels. The ECU is connected to a central unit that connects the control panel, display, reception sensor for the remote control, and a camera sensor that detects areas of the floor not yet cleaned. Finally, there is a power switch on the back of the device connected to the lithium-ion battery on the bottom and the fuse box on the top. To view the artifacts of the logical architecture, the software or hardware requirements, or the test specifications that are linked to the blocks of the logical architecture, we open the corresponding link tables. For example, let's open the logical architecture link table. We expand the contents of the left column in the logical system architecture table. The table shows that the logical terrain localization sense is implemented by the process units of the 3 ultrasonic sensors and the cliff sensor. The process units of the LiDAR implements intruder localization. To view more details, open the Hardware Detail Design category in the Explorer. For example, let's open the component diagram of the ECU implementing the central navigation and routing system to see its internal structure. The ECU contains a microcontroller, a process unit, memory modules, and the conventional and bus connectors for the sensors, LiDAR, motors, and central unit. To trace the connections of external devices to the component's connectors, place the network diagram next to the component diagram. Let's adjust the display to fit the windows. Now, when we select a component or connector in one diagram, it is automatically selected in the other. This makes tracing connections across diagrams easy. To view the hardware requirements or test specifications linked to the components of the hardware architecture, open the corresponding link table. Let's open the Hardware Requirements link table. In the Hardware Detail Design table, we expand the contents of the left column. The right column of the table shows the hardware requirements assigned to the process unit of the central navigation and routing system. This concludes our tutorial series on model-based systems engineering with PREEvision. We hope you enjoyed the walkthrough of developing a robot vacuum cleaner using the RFLP approach and PREEvision's System Engineering Explorer. Would you like to check out model-based systems engineering with PREEvision for yourself? Go for it. We offer the example model from our tutorial in a hosted PREEvision environment. There, you can perform the tutorial steps yourself using PREEvision. If you are interested, please visit preevision.com/trial. Thanks for watching. Goodbye.